Hello everyone, welcome to my YouTube channel. Let's do self-study. We will be discussing number system from class 9 and our reference will be NCERT book. So when we talk of number system, what we are talking about is real number. You must have heard this real number line, and on this real number line there are infinite numbers of real number between any 2 points. So we know that all natural numbers are whole number. All natural numbers are whole number. But reverse is not true. Like all whole numbers are not natural number. Why? Because this is zero. The zero is a whole number, but it is not natural number. So that is why all whole numbers are not natural number. Most of it are. Most of it are definitely are. Only zero is that is not included in the natural number. And next is all whole numbers are integers. You can see all whole numbers are integer, but negative integers are not whole number. So all integers are not whole number. All integers are rational number. Why? Because all integers we can write it in the form of p by q, where q is 1, like 3 by 1, 4 by 1, minus 3 by 1. So all integers are rational number, but all rational numbers are not integer, like 2 by 3, 3 by 4, 3 by 5. These are rational number, but these are not integer. So that this is what I was talking about, the real number family. And real number family is basically broadly divided between rational number and irrational number. And rational numbers includes integers, integers includes whole numbers, and whole numbers includes natural numbers. So we are going from broad definition to specific definition. Like you can see this graph, Venn diagram. So this is the real number. All number belongs to real number family. One part is irrational number, another part is rational number. In the rational number we have integers. In the integers we have whole numbers, and we have natural numbers. So all natural numbers are whole number, all whole numbers are integer, and all integers are rational number, and all rational numbers are real number, and all irrational number are also real number. So this is what the meaning of this diagram. We will do some problems. It is better if you can do the problem yourself, because I am referring to NCERT book. So you can do the whole exercise number 1 yourself, and then you can continue the video. First question is 0 a rational number? Is 0 a rational number? Of course 0 is a rational number, because 0 can be written in the form of 0 by 1 p by q, where q is not 0. Here q is 1, p is 0, but q is 1. So 0 is a rational number because it can be written in the form of p by q. Find 6 rational numbers between 3 and 4. So can you tell me how many rational numbers or how many real numbers exist between 3 and 4? So between any two numbers there exist infinite numbers, infinite real numbers, and those real numbers can be rational or irrational. So there exist infinite numbers of numbers between any 2 points on the number line. So between 3 and 4 is the problem is to find 6 of them. So if there is infinite number of them, you can find any of them, right? Like between 3 and 4, 3.01, 3.02, 3.35, 3.25, right? So, but we can find it in some different way. Let us see, on the number line it is 3 and 4. So what is the midpoint of this? 3 plus 4 by 2, that is 7 by 2. Now we will find the midpoint of 7 by 2 and 3. So that is 13 by 4. And we will find midpoint of 7 by 2 and 4, that is 15 by 4. Further, we can further divide it, like the midpoint of 13 by 4 and 3, that is 25 by 8. Midpoint of 13 by 4 and 7 by 2, that is 27 by 8. Midpoint of 7 by 2 and 15 by 4, that is 29 by 8. So how to find the midpoint? You sum the two number and divide it by 2. So like if I ask you to find the midpoint of 5 and 10, so you get this 5 plus 10 by 2, that is 7.5, right? So like midpoint of 4 and 6 is 4 plus 6 by 2. So likewise I have divided, further subdivided each point to its midpoint. So all these points lies between 3 and 4. So this is one way. You can see there is so much of calculation, and you can find that okay, between 3 and 4 lies 25 by 8, 13 by 4, 27 by 8, 7 by 2, 29 by 8, 15 by 4, 31 by 8. So all these numbers lies between 3 and 4. And other easy way to find rational numbers between 3 and 4, if you have to been told to find 6 of them, then what you have to do, you make numerator and denominator you multiply with. If you have been asked 6, then you 6 plus 1 you multiply with 7. So write 3 as 21 by 7. You can write it, right? Like 3 into 7 divided by 7. So you can write the 3 as 21 by 7 and 4 as 28 by 7. 4 into 7 by 7. So we have like 3 is same as 21 by 7 and 4 is same as 28 by 7. Like 7 fours are 28 and 7 threes are 21. So likewise, like 21 by 7 and 28 by 7. So what are all the numbers, real numbers, which lies between 21 by 7 and 28 by 7? 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7, 27 by 7. So these are the 6 numbers which lies between 3 and 4. But these are something which we have find by some kind of definition. But it is not necessary that these are the only numbers between 3 and 4. There are infinite number of them, as we know it, and it can be anything. Answer can be any number between 3 and 4. We have found some of them with our definitions, right? So the next one is find 5 rational numbers between 3 by 5 and 4 by 5. So we will try to do it in the easy way. So it is written 5, so we will multiply with 6. 5 plus 1. So 3 into 6 divided by 5 into 6. That becomes 18 by 30. And 4 by 5 becomes 24 by 30. So you know it. What will be these numbers? 19 by 30, 20 by 30, 21 by 30, 22 by 30, 23 by 30. So all these numbers lies between 3 by 5 and 4 by 5. You must have understood that 3 by 5 is same as 18 by 30, right? And 4 by 5 is same as 24 by 30. Okay, so state true or false. Every natural number is a whole number. Every natural number is a whole number. So that's true, because every natural number is what? It is counting number. So whole number is counting number plus 0. So that is whole number. So all natural numbers are definitely whole number, but all whole numbers are not natural number. That we know. Every integer is a whole number. No, every whole number is an integer. That's correct, but every integer is not a whole number, because negative integers are not whole number. Every rational number is a whole number. Every rational number can't be a whole number, right? Like integer itself is not a whole number, so every rational number is also not a whole number. Like rational numbers like 2 by 3, 3 by 4, these all are not whole number. Like rational number is 3 also, that is whole number, but not all the rational numbers are whole numbers. This we know. So how will you be represent irrational number on number line? So we know the Pythagoras theorem, a square plus b square equals to c square, where this is c, this is a, this is b. So if a and b are 1, then a square plus b square is 1 plus 1, 2. 1 square plus 1 square, 2. And this hypotenuse is, if it is 1 and this is also 1, then this hypotenuse is root 2. And we can take a compass and we can make it make the same length on the number line, and that will represent root 2 on the number line. So this is how we can represent root 2 on a number line. Likewise, we can represent any number, any rational number on a number line which are of the form of square root, like root 2, root 3. If we have to represent root 3, then we know this is root 2, then we will make one perpendicular line to root 2 and of length 1. So this is root 2 and 1. So what will be that? Root 2 square plus 1 square, square root of that. So that is root 3. You can go on with root 3, root 4. You can make perpendicular to root 3 and make a length of 1. So this will become root 4. Likewise, from root 4 you can make root 5. There is another way you can make the root 5, like you go make a perpendicular of length 1 at the number point 2, and so this will be a square root of 2 square plus 1 square, that is root 5. And you can draw the same length arc, and that will cut on the number line, and this length will be root 5. All points on a circle are equidistant from the center. If you make a circle from center O, so if it is the radius is root 5, so when it cuts the number line, that will also be root 5. We are making a circle, arc of a circle. Decimal expansion. So if we have number 10 by 3 and we want to write it in the decimal form, so we will divide it, right? So 3 3s are 9, so 10 minus 9 is 1, again 0, and 3 3s are 9, again 0. So you can see the remainder. Actually we need to see what is the remainder. When you divide 10 by 3, what is the remainder? The first remainder is 1, and when we divide again, the remainder comes 1. So what will happen? This will continue, go on repeating if you go on dividing. So we will continue to get 3.3333 infinite times. So this is repeating. So this is non-terminating repeating decimal. So 10 by 3 is 3.3333 infinite times. So we write it as 3.3 and we make a 1 bar above 3. The numbers which are repeating. So here only 3 is repeating. So we write it as 3.3 and bar over 3. So that is remainder 1 is repeating here. If we have 7 by 3, so that is 0.875, and this is terminating decimal. This is terminating because it has ended at 5, like it has, the remainder has become 0. So if remainder has become 0, then the number, the decimal we can write as 0.875, right? So if you divide 1 by 7, so what are the remainders that are coming? The first time it comes as 3. First time the remainder is 3. Next time the remainder is 2. Next time the remainder is 6. Next time the remainder is 4. Next time remainder is 5. Then the remainder is 1. Then remainder comes 3. So when the remainder starts to repeat, then the same division will continue. Like when it comes to 3, then again the same process will continue. Like 7 4s are 28. So what will be repeating, from where it will be repeating? This is the number where it has started to repeat, but we are missing one point. This is the number where it has started to repeat, right? The first number itself, so which block will be repeating after 7? 7 7s is 49, then it comes 1, and 7 1s are 1. So after 1 4 2 8 5 7, the next number will be 1, right? 1, and then again it will come 4, then again 2, then 8 5 7, and then again 1, then again 4 2 8 5 7, then again comes 1. So likewise, if you continue go on dividing, it will continue to repeat, and the what will be repeating? A block of number. It is not like, so what is the 1 by, what is the value of 1 by 7? 0.142857, and after that it will start repeating 14285 7. It will continue repeating. If you go on dividing, it will, the same block of number will be keep coming back. So this is non-terminating but repeating decimal. So rational numbers can be terminating decimal or non-terminating recurring. Non-terminating repeating decimal, okay, or recurring decimal. And irrational numbers are non-terminating and non-recurring. Let us do one exercise. Every irrational number is a real number. Every irrational number is a real number, because this is a real number family. Real number family includes irrational and rational, both of them. So every irrational number is a real number. Why? Because we can plot irrational number on a number line, and irrational number, there is existence of the irrational number on the number line. So every irrational number is a real number. Every point on the number line is of the form root m, where m is a natural number. Root 3 by is a real number, but 2 by 3 is not natural number. So there are infinite number of points of a number on a number line. So it is not necessary that root m, all the numbers can be written in the form of root m, where m is a natural number. It's not true, because root 2 by 3 is a real number, but 2 by 3 is not a natural number. So likewise, there can be many more such points which are where root m and m is not a natural number. Like root 5 by 7. M is not a natural number. Every real number is an irrational number. Every real number is an irrational number. It's false. Why? Because real numbers include rational and irrational, both of them. Are the square roots of all positive integers irrational? If not, give an example of the square root of number that is rational number. Square root of all positive integers, like a square root of 4 is 2, so that is rational number. So a square root of all positive number can't be irrational, but root 2 is irrational, right? So 2 is a positive number and square root of 2 is irrational number. But the square root of 16 is 4. 16 is a positive integer, and square root is also a positive integer. So that is not true.
Oi, Papa, it's not that about you. You will do.
Represent root 5 on number line. So to represent any number on a number line, you have to first represent 1 minus of that. Like you have to represent root 5, then you go to root 5 minus 1. So if you can represent root 5 minus 1, you can start from there. If you cannot, then you have to go 1 before of that and continue going there till you get a point which you can easily plot on a number line. So here we can plot root 5 minus 1 on number line, because root 5 minus 1 is 2. Like 5 minus 1 is 4, and the square root of that is 2. Construct a square root spiral, that we have already done. Okay, so we will continue with our exercise. I will suggest first you do it yourself and then come back here, so that will help more. Write in decimal form and say what kind of decimal expansion each has. We have to write in decimal form 36 by 100. You have to write it in the decimal form. So if you divide it, you will get it 0.36. And this is terminating decimal number. Likewise, 1 by 11. This is non-terminating repeating decimal. 4 1 by 8, you can write it as 33 by 8, like 4 times 8 is 32 plus 1, 33 by 8. And if you divide it, you will get 4.125. So this is terminating decimal number. 3 by 13, this is non-terminating repeating decimal. And you can see here a very big block of numbers are repeating. So you have to see where it starts to repeat, you have to watch the remainders. You have to see which remainder is coming, and if the remainder starts to repeat, the same block will come. You can do it yourself and understand how the block starts to repeat. Two by 11, you can see this 1 8 is starts to repeat itself. Like first of all, 11 ones are 11, remainder is 9, and 11 8s are 88, remainder is 2. So this is the first number 2 and this 2. This started to repeat itself. and you will, if you go and continue dividing, you will continue to get 181818. So 2 by 11 is 18, repeating 18. 329 by 400, you can try to divide it and get this number. So this is terminating decimal number, and 1 by 7 is non-terminating recurring decimal, because this block of number starts to repeat itself. And this is another problem. We have to 1 by 7 is 0.142857, and this 142857 continues to repeat. So we have to predict 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 without long division. So to understand that, what we will do is we will see the division of process of 1 by 7. So we are dividing 1 with 7. So the first remainder comes is 3, second remainder that comes is 2, then the remainder comes is 6, then the remainder comes is 4, then 5, then 1, right? So for 1 by 7 it starts with 1 and then 1.0, so that is 10, right? So for 1 it is 10, you start with 10, number 10, and 7 1 just 7, so start with number 1. And if you start with 3 number, so if you divide 3 with 7, so it will start with 30. If you start go for 2 by 7, so it will start with number 20, right? And after that the same block will repeat, right? So for 1 by 7 it is 142857. Then 3 by 7 it will be, what will become, that 1 will come at the last and it will start with 4.42857, and then comes 1. So it will be, after that, after this one again it will come 428571, 428571, right? And for, if it is for 2 by 7, this 4 will go into the last position. So 285714, 285714, 285714. So that this is how it will repeat for 2 by 7. For 6 by 7, you can see how one beautiful it is, right? The same number starts to repeat, but the places are getting shifted, and you can understand it by doing it yourself. You do it and then you can understand it, how it is expressed in the form of p by q, where p and q are integers and q not equals to 0. You have to write this decimal number in the form of p by q. Point 6, 0.47. So these are easy ones, you can try it yourself. You can pause it if you do not, if you want help, you can see it, pause and watch it. You do it yourself and you will understand the procedure. And this one is very interesting. You have to express 0.999, like zero point 0.9, as a repeating decimal in p by q form. So let us say x is 0.999 repeating 9. So we will multiply it with 10. So 10x is 9.999, that is the same repeating decimal. And we will subtract equation 2 with from 1. So 10x minus x is 9x, and 9.999 minus 0.999 is 9. And what it becomes is x is 1. So you can you see that 0.9 recurring is 1. Like, how did this happen? 0.9 recurring becomes 1. How? You can visualize this with this approximation. Like 0.9 is very close to 1. but 0.99 is more closer to 1. 0.999 is just very close to 1, and if you continue doing it with to infinite times, it is like not approximately but exactly equal to 1. When it goes to infinity, point 0.9 repeats itself to infinity, then this number is exactly equal to 1. You do not have to say approximately, but it is exactly equal to 1, and that we have proved with the same procedure which we have followed for the other numbers. Maximum number of digit in repeating blocks for 1 by 17. So what is the maximum number of digit that is repeating? So you have to divide and find out. You have to do it yourself. You have to see from where it starts to repeat. You have to see the remainder. So the first remainder is 10. Next is 15. Next is 14. Next is 4. Then 6. Then 9. Then 5. Then 16. Then 7. Then 6. So this 6 repeats itself. So when the remainder repeats itself, after that the same block will continue coming. So from 35294, this number will continue to repeat itself. So 1 by 17 is 0.05882, then 35294, 35294, 35294. So this will continue. This block of number 35294, that is 5 numbers of them, 5 digit 35294. These numbers will be, this is the number of digit that is repeating itself. There is one question that you have to see what kind of fractions or what kind of rational numbers are terminating and what kind of rational numbers are non-terminating decimals. So you have to see this. Like 1 by 2 is 0.5, 1 by 3 is a non-terminating decimal, 1 by 2 is terminating decimal, 1 by 4 is also terminating, 1 by 5 is also terminating, 1 by 6 is non-terminating, 1 by 7 is non-terminating, 1 by 8 is terminating, 1 by 10 is terminating, but 1 by 9 is non-terminating, 1 by 11 is non-terminating. So what if you observe it very carefully, you will find that the terminating decimal has a peculiar point that the denominator of all these numbers are either the power of 2 or power of 5 or both of them or multiplication of them, right? So 2 into 5, 5 into 4, 4 into 125, like that. So denominator for rational numbers to be a terminating decimal, its denominator has to be power of 2 or 5 or both. So denominator has to be the power of 2, like 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, or 5 to the power 1, 5 to the power 2. So it has to be in the multiples of that only. Otherwise, these numbers will not be terminating. This will be non-terminating and non-terminating. But if it is rational number, so it will be a repeating number. Like if it is irrational, then it will be non-terminating, non-repeating. So we are not talking of irrational number, we are only talking rational number. So for rational number, if denominator is power of 2 or 5 or both of them, like 2 to the power 5 into 5 to the power 5. So if it is multiply both of them, and if that is the denominator, then also it is that rational number will be terminating decimal number. And if it is not like that, if the denominator is 3, 6, 9, 11, 12, 17, 15 will be terminating. But 3, 6, 9, this will be non-terminating. Okay, so what we will do now, write numbers whose decimal expansion are non-terminating, non-recurring. Write 3 numbers whose decimal expansion are non-terminating, non-recurring. all irrational numbers are non-terminating, non-recurring. Find three irrational numbers between 5 by 7 and 9 by 11. You have to read it, pause and read it. Classify following as rational or irrational. So root 23 is not perfect square of any number, so root 23 is irrational. Root 225 is 15, so that is rational. 0.3796 can be written in the form of PYQ. And this number is non-terminating but repeating number, so this is rational number. And this is non-terminating and non-repeating because you can see the number of zeros between 1 are increasing. So 1.01, 0001, 0001 and 44000001. So this is non-repeating, non-terminating and non-repeating. So this is irrational number. So if it is non-terminating, non-repeating, then this is irrational. So that is the only one class of numbers that is irrational. If it is terminating decimal, it is rational. If it is non-terminating but repeating or recurring decimal, then that is also a rational number. But if it is non-terminating, non-repeating or non-recurring, then that number is irrational number. Successive magnification of real number line. So I told you that on the number line that lies infinite number of points, right? So you can go on magnifying the number line and you can see all the numbers between them. Like between 1 and 2 lies 1.25, 1.5, 1.75. If you magnify 1.25 to 1.5, you have these numbers. Likewise, like you can magnify any two point and you can see, go on seeing that there lies so many points. And even the irrational numbers, at least you can approximately tell that this numbers lies between this and this number. So you can approximately plot the irrational numbers as well. For root 2 you can plot it exactly as well. Operations on real number. So like 3 plus 5 is equal to 5 plus 3. So that is called commutative law. We know it like for sure, we take it for granted. But this comes from a law like 3 plus 5 is equal to 5 plus 3. So addition and multiplication follows commutative law of addition and multiplication. But 3 minus 5 is not equal to 5 minus 3. So the subtraction does not follow commutative law. Like 3 by 5 is not equal to 5 by 3. So the division also does not follow commutative law. Only addition and multiplication follows commutative law. You can prove it as well. And when you study math, you should start thinking of proof. In everything, you should think of proof. What is the proof of this? You have to start from first principle for most of the things. And then you can understand and visualize problems and you can study maths in a better way. So all problems you have to start with a law. Where is the law? So you have to understand those laws. So you always know that 3 plus 5 is 5 plus 3. You always knew that. But did you knew that this comes from commutative law of addition? And this law has come from where? That has also come from the first principle. Like 3 plus 5 is 5 plus 3. Why 3 plus 5 is 5 plus 3? Because 1, 2, 3. Does it matter in which order you add the numbers? It does not matter. Like if you add 3 and 5 or 5 and 3, the order of addition does not matter. Both of them are still 8. So this is the proof of that. That is what I'm telling. This is not like something law has come, but the law has some proof. So all the mathematical expression, all the formulas you study that has some proof, and you need to find out what is the proof of that. So that is commutative law, distributive law. Like 3 times 2 plus 4 is 3 3 times 2 plus 3 times 4. You distributed this. And associative law, 3 plus 5 plus 7 is equal to 3 plus 5 plus 7. So which way you add first does not matter. That is also true for multiplication. So this is the rational number, for sure you know that, and irrational numbers also follows these laws: commutative law, distributive law, associative law. Even irrational number follows this because all these are real numbers only. So if you, when you add it, then it follows the same principle of addition and multiplication. And this is very interesting. Represent root x on number line, right? So if you have to represent root x on number line, so what will you do? We will take one line AB, that is of length x. AB is equal to x and BC is equal to 1. We will find the midpoint of this. So x plus 1 by 2 is the midpoint of this. AC is equal to x plus 1. So AO is equal to x plus 1 by 2. So that is the midpoint of this. And with this OA as a radius, we make a semicircle. And at the point B, that is AB is equal to x, we make a perpendicular line. So we know this OD is x plus 1 by 2, and OB, what will be OB? That will be x plus 1 by 2 minus 1. So if you do that, it will become x minus 1 by 2. You try to do it yourself. So on this triangle, this is x plus 1 by 2, x minus 1 by 2, and you try to find out this. Yeah, I have done this exercise, and it comes root x. And when you got this BD is equal to root x, you can take the protector and make it arc of this with the radius BD. So BD is equal to BE, and this BE is equal to root x. So this way you can plot this on a number line as well. Exercise: classify as rational or irrational number. 2 minus root 5. So root 5 is how much? 2.236, and it will continue to repeating, like non-repeating, but it will continue to go on, non-terminating, non-repeating, right? So if you subtract from it 2, so 2 will go off, but still then the non-repeating part will still stay. So 2 minus root 5 is still a irrational number. So this is a rule as well, like rational minus irrational is irrational only. So 2 minus root 5 is irrational. 3 plus root 23 minus root 23. So these are both of them have become 0. So it has become only 3. So this is rational number. This can be written in the form of p by q. So this is also rational number. And this is rational number divided by irrational number. So if you divide a rational number with an irrational number, so that is also irrational number, because it will continue to repeat itself. So this is 1 by root 2 is also irrational. 2 times pi, rational times irrational, is also irrational. So if you multiply it, but the number which was not repeating but going to infinity, so that will continue to continue like that, not repeating, but it will go to infinity. The number of numbers of digits after decimal point will be infinite. We have to simplify this expression, so we will use this distributive law. This is also simple. A plus b into a minus b is equal to a square minus b square, and you can prove it like this. Root 5 plus root 2 whole square. This is a plus b to whole square, a square plus b square plus 2ab. And the same thing, you can prove it like this. This is a square plus 2ab plus b square. And you can prove it with the distributive law. This is again a minus b into a plus b. That is a square minus b square. That is root 5 square minus 2 square. That is 5 minus 2 is 3. This is interesting problem. We know that pi is a ratio of circumference to diameter. Do you know that? Circumference is how much? 2 pi r or pi into d. Pi into diameter. So C is what? Circumference is pi into d divided by d. So if d got cancelled, so that becomes pi. So from there also you know pi is what? Circumference divided by diameter. So that is the ratio of circumference to diameter. So you can see pi has been written in the PYQ form CYD. So why it is irrational? If we can write it in the form of PYQ, because C and D are not rational number, right? We have written PYQ form, but P and Q both has to be rational. Then only the number will be rational number. If P and Q are not rational, then the number is also not rational. So this is CYD. C and D both are not. Both can be irrational number. Both of them can be irrational, right? So ratio of that will again be irrational. So C writing in the form of C by D does not mean this is a rational number. So if pi has been written in P by Q form, how is it irrational? P by Q is rational only if both P and Q are rational. But here C and D both can be rational or irrational. So we know that rational divided by irrational is always irrational. Represent root 9.3 on number line, like root x. That is what we learned earlier. How to represent root x on number line. Any x. So how we will do? We will make a line, take a line AB equals to 9.3 and a point PC is equal to 1. Then we will take the midpoint of this AC 9.3 plus 1 by 2, that is this AO, and OB is 9.3 plus 1 by 2 minus BC, that is 1. So that becomes 9.3 minus 1 by 2. And the same now thing, you can see this OB is 9.3 minus 1 by 2, and this is the radius. So both will be same. AO and OD will be same. AO and OD 9.3 plus 1 by 2. And if you find out, you will see that BD is root 9.3. And if you take the center as B and radius as BD and make with protector, you make a semicircle or arc, then this will cut the number line at E. The BE will be root 9.3. You can pause the video. Always you can pause the video and understand it. Rationalize the denominator. 1 by root 7. You multiply both with root 7, it becomes root 7 by 7. So number has been 7, denominator has become rational. 1 by a minus b. So you have to multiply with a plus b. So a minus b into a plus b, a square minus b square. So this is the formula which has been used in all these expressions. Law of exponent for real numbers. We know that a to the power m into a to the power n is a to the power m plus n. And how it is, if you want to know the proof of it, as I said, all the mathematical expression has some proof. So like 2 to the power 3 into 2 to the power 2, so is equal to 2 to the power 3 plus 2. Why do we write like this? Why we write like this? Why? Because 2 to the power 3 is what? 2 into 2 into 2 3 times, and 2 into 2 is what? 2 into 2. So how many times this 2 has been multiplied? 1 2 3 1 2. So this power has been added, right? So that is why we write a to the power m into a to the power n. So a has been multiplied m times and a has been multiplied n times. So if you multiply both of them, so a has been multiplied m plus n times. Like a m plus n times. So that is the proof of it. When you study mathematics, you have to ask the proof of it. Like this, why it has been multiplied like 2 to the power 3 to the power 2, right? So what it will be 2 to the power 3 into 2 to the power 3 two times, because this is the power of that. So what it becomes 2 3 into 2, right? Like 3 plus 2, like if it is 2, it is already multiplied 2 times. So this is the proof of it. A to the power m whole to the power n is a to the power m times n, mn. So this is very crucial to understand. Like the same way, we can see for this 2 to the power 5 divided by 2 to the power 3. So what it will be? 2 multiplied 5 times, 2, 2, 3 times, 4 times, 5 times, divided by 2 multiplied 3 times. So how many of them this will go? 2, 2, 3. So how many will be remaining? 2. So that will be 2 to the power 5 minus 3. So this is how a to the power m divided by a to the power n is a to the power m by n, right? But if, let us think this numbers are reversed, right? If it is 3 and this is 5, so what it will become? Right? And this will be right. So what it will become? 2 to the power 3 minus 5, right? So it will become 2 to the power minus 2. So that this is why we say if the power is negative, then you have to inverse it, right? So if it is 2 by 2 is same as 2 by 1, so you have to write 1 by 2, 1 by 2 to the power 2. Why? You can see from here. So if the power on the denominator is more, so some of them will be left on the denominator. So if the power is negative, it means you have to inverse the number. So if it is 2, so 2 to the power minus 2 is 1 by 2 to the power 2. So you have to understand this. What the negative power means. What is the meaning of negative power? So but the power is negative, but the number will still be positive. You have to understand this, that for any positive number, whatever is the power, whether it is positive, negative or 0, the number is always positive. That interesting part is, what is the 2 to the power 0? 2 to the power 0 is how much? What does it indicate? 2 to the power 0 is 1. So why we say this 2 to the power 0 is 1? Why? If you say that 2 to the power 3 and 2 to the power 3, both of them are 2 to the power 3, so 3 minus 3 is 0, right? So that becomes 3 minus 3 is 0, so 2 to the power 0. So both of them cancel each other, but still the number is 1, it is not 0. So 2 to the power 0 is 1. Likewise, a to the power m, b to the power m, you try to prove it yourself. With the example of a is equal to 2 and b is equal to 3, or any number, you try to prove it. Exercise. So this exercise is simple. If you understand this, you can do it very easily. And if power is 1 by 2, if the power is fraction, what does it mean? 64 to the power 1 by 2, right? So if we multiply this with the same number, 64 to the power 1 by 2, what it will become? 64 to the power, we know that the power sums itself, right? So this will be 1 by 2 plus 1 by 2, that is 1. So that is equal to 64. So what does this mean? If you multiply the same number by itself, it becomes 64. So 1 by 2 means square root of it, right? What does this mean? The 64 to the power 1 by 2 is same as square root of 64. Because if you multiply this with itself, it will become 64. You have learned it with the addition of power. So likewise, if you say that 64 to the power 1 by 3, so if you multiply it 3 times, it will become 64, because 1 by 3 plus 1 by 3 plus 1 by 3 is 1, right? So the same thing, right? If you give the power to it 3, right? So what it will become? 64. So cube of this is this number. So this means this is the cube root of 64, right? This is cube. If you give the power, right, like this. So if you remove the power 3, then the same thing, you should understand this. So if you can understand, 64 to the power 1 by 3 is cube root of 64. So this is from where this is definition is coming. Like 64 to the power 1 by 3 is cube root of 64. You can try to do it for yourself for other numbers, and you can understand. And this exercise is from the NCERT book. Yeah, we have to write it in the simplified form. So I have tried my best to write it. You can pause the video and see it. So this is all for the number system, and what we studied in the number system. So whatever we have studied, this is a summary of that, and this is very important. This is the summary of the number system. This is the last page. Read it yourself. This is important.
Why?
Read all of this.
No.
Okay, thank you. Okay, so thank you for watching. Have a great self-study time. Give time to books and study yourself. Solve problems yourself. Do not look for help in the first stance. Try to solve it yourself, and you will see how the wonders happening. Okay, thank you. Bye bye.